Hey there YouTube, this is SGM4306 and I'm just sitting here writing code for my newest project, which was, I've 3D printed already the front cart cover, I guess you could call this, for the NES micro project I'm working on. Here I'm in MP Lab writing the firmware for the actual battery meter and power controller. And so if I just zoom down, you can see here I have it currently running, and you can see here in standby it draws about 390, oops, accidentally reset the controller, about 390 some microamps. So just by calculations, this is in standby. So calculations for a 2500 milliamp hour battery, that would give us about 6500 hours of standby time. So in days, that's 267 days, which is, I think, good enough for something that I would probably charge fairly often anyway, depending on use, obviously. But one thing to note is I think maybe I'm missing some of the peripherals I haven't powered down properly, because I've definitely got this this chip down to about the 20 microamp range before, if you properly shut everything off. And only enable the interrupt to actually wake it back up. So definitely I think I can cut this number by an order of magnitude, which would, increase the standby time by an order of magnitude. Anyway, this is good enough now for a test. So I'm going to bump this up to the 20 milliamp range and show you guys. It does have this interesting thing. Once it shuts off, it takes a little while for the current draw to drop down. But when you first plug in a battery or something, it'll turn on briefly and then go into sleep mode. So to wake it, you have to press and hold the button for a little while. And this is the power. This LED represents power going to the NES. And the 4 LEDs here along the top represent the battery meter. And so if I grab a screwdriver, I have a potentiometer that represents the lithium battery. So here, I can tweak it down slowly. You can see the LEDs going off. When it gets to 1 LED, if you tweak it down a little bit more, it will start flashing at about a 1 hertz rate to let you know that the battery is low and that you need to recharge the system. So if you're playing a game with a save, you should probably at that point go and hurry up and save, shut off, and then recharge the battery. But anyway, you can see that the battery meter works. And to shut it off, all you have to do is press and hold this button for a little while, and then it shuts off. You can see the current drops down, and then it sort of decays like a capacitive decay down to the settling current of about 300 and something microamps, which we will hit shortly. Yeah, about 400 maybe. So yeah, all in all, that's the controller itself working. I have used every single pin on this microprocessor. So one of the pins is dedicated to reading the battery input. One of the pins is dedicated to turning on the NES and turning it off. And I have 4 LEDs, but I've actually charlieplexed these. So I'm pulsing them. I'm only using 3 pins to drive 4 LEDs, and I'm pulsing them in such a way that only 1 LED is on at a time. And I basically have them anti-parallel cascaded. So I was able to get away with only 3 lines for the LEDs. And the cool thing is, because I'm charlieplexing the LEDs, I could actually modulate the brightness as well by changing the duty. So yeah, this is everything so far. I've already designed a little board that will basically follows this exact same schematic. So all I got to do is wait till that board comes in, solder it up, and test the actual circuit, make sure I didn't screw up on the schematic. But anyway, yeah, it's firmware-wise all working right now. I'm going to work on getting this current figure down considerably. Hopefully it's just something simple, like I forgot to turn off a comparator or something on the chip. But yeah, all in all, we are good to go. Can't wait to 3D print the rest of the parts. This guy took something like 5 hours, and the top and the bottom cases will probably take like another 10 to 15 hours total to print both of them combined. So I have a lot of printing to do. Oh my goodness. But yeah, all in all, this came out pretty well actually. You can see kind of the detail. The board lies in here. I created some like a shadow box for the LEDs. I'm going to be using surface mount LEDs, and got to figure out how to plug these holes. I might try what I did before, which was put a piece of tape on the front and put a little bit of hot glue. Or another good idea would be epoxy, actually. That'd probably be better, as long as it's sealed perfectly tight on the top. I just put a little bit of epoxy. It'll create like a clear window, and that'll be good. Yeah, so all in all, this I've already kind of tested this for the card, and it slides in with just enough wiggle room for you. And there should be hopefully enough room for the circuit board to lie flat along the top there. So yeah, hopefully you guys enjoy the video. I just wanted to give you guys a quick update on the firmware that I've written. And yeah, I'll keep you updated as more progress proceeds. So until the next time, bye.